Okay, so let's see what Val is doing. So it says Val jogged 6 miles east, 3 miles south, 1 mile east, 2 miles south, 4 miles west. How far was she from where she started? Right, what has happened? She's going east, she's going south, she's going east, she's going south. And then it's like, oh no, I passed my house. Let me backtrack. Does that make sense? That's where the west comes in. So she's going east, south, and then it's like, oh no, I passed where I needed to be. Let me backtrack. So let's see what we're going to do here. So I had told you guys to make a right triangle. Do you all remember that from yesterday? And I said the vertical segment in this right triangle is going to be our north and or south, right? And then the bottom side of this right triangle represents the east and or west. And we're always trying to find the hypotenuse. So let's see. We had 3 south, then 2 south. So what's the total for our south? 5 south. Where is that going? Vertical or horizontal? Vertical. All right, then we have 6 east, 1 east, but then 4 west. What do you think I have to do with the 6, the 1, and the 4? Any guesses here? Sam? So I'm going to add the 6 and the 1 for sure. Divide it? Nope, so we're going east, we're going east, we're going east. Oh no, I passed my house, let me go back. You're going to subtract it. So we're going to do 6 plus 1, and then what? Minus 4, exactly. And 6 plus 1 is 7, minus 4 is 3. And now we do the Pythagorean theorem. So we are 3 squared plus 5 squared equals x squared. 9 plus 25 equals x squared. 34 equals x squared. Any pairs for 34? Nope. So how far is she from where she started? Root 34 units long. Or far, I should say. Okay, so definitely anticipate a little trick in your word problem, maybe on the quiz, maybe on the test, maybe on both, who knows. Okay, so today I am going to give you some things to memorize. I'm going to give you some things to memorize. Okay, we know that the Pythagorean theorem is a squared plus b squared equals c squared, right? C is always the hypotenuse. But there's certain triangles that are more popular than others. What do I mean? If I have a right triangle and one leg is 3 and one leg is 4, right, and we do the Pythagorean theorem, this is 3 squared plus 4 squared equals x squared. This is 9 plus 16 equals x squared. 25 equals x squared. What does x equal? 5, right? This is a very popular Pythagorean theorem where one leg is 3, one leg is 4, the hypotenuse is 5. Right? And there's a bunch of very special ones that show up a lot. So these very special ones are called Pythagorean triples, meaning when these show up, don't waste your time doing the Pythagorean theorem, just memorize them. They show up on SATs, they show up on ACTs, and we all know with those standardized tests, time is an issue, right? So you really want to cut out the time of doing work and just know these, have them memorized. They show up in pre-calc. So let's go through this. These are the triples I want you to memorize. Now, in every single one of these, the last one is the hypotenuse. So if one leg is 3, one leg is 4, the hypotenuse is 5. If one leg is 5, one leg is 12, the hypotenuse has to be 13. 7, 24, which one's the hypotenuse? 25. 8, 15, 17, which one's the hypotenuse? 17. 9, 40, 41, which one's the hypotenuse? 41. So let me give you, it'd be like the first time in math and you're going to hear, I don't want you to show me work. So if I gave you a right triangle and I said, first example, that one leg is 7, one leg is 24, I want you to find x. What does x have to be? 7, 24, 25. Just like that because we have it memorized. Right? But sometimes I won't have the hypotenuse missing. So for example, if I say this side is 17 and this side is 8. So the hypotenuse is 17, one of the legs is 8. Which Pythagorean triple are we looking at? Good. 8, 15, 17. Do we understand how this works? All right. But be very careful. If I say one leg is 3 and one leg is 5, and I want you to find the hypotenuse, is this a 3, 4, 5? Is this a 3, 4, 5? Good. Why? How do I know this is not a triple? This is not a 3, 4, 5. Oscar.
Because the 5 is one of the legs.
Exactly. So this is not a triple. Must do Pythagorean theorem. We good? Sure, I'll wait. Okay. Okay. So now we have a principle of reducing or enlarging a triangle, meaning we can manipulate the triangles to make it, by creating similar triangles, to make the problem easier for us. So for example, that should be a fraction bar. All right, so here we have 4, 7.5, and I want us to find x. Right now, 4 and 7.5, is it a triple? No, it is not a triple. Do you think the Pythagorean theorem on fractions or decimals would be fun? No. Pythagorean theorem on fractions and or decimals are not fun. So what are we going to do? We are going to create a similar triangle to this. And this similar triangle, you either reduce or enlarge. So you can multiply or you can divide. Those are your only options, the whole entire triangle. So now I'm going to take this whole entire triangle and now I'm going to think, what can I multiply 7.5 by to get it to be a whole number, not a fraction? Maya? Yeah, multiply by 2. So I'm going to multiply the whole entire triangle by 2. And when I multiply the whole entire triangle by 2, I get a new bigger triangle. So 4 times 2 is 8. 7.5 times 2, 7.5 times 2 is 15. We are solving for the missing side. This is a triple. Go back. 8, 15. 17, 8, 15, 17. Does that mean x is 17? No, because what did I do? I multiplied by 2. So to go back, what should I do?
Divide by 2.
Divide by 2. So x is not 17. X is 17 over 2. No, you can leave it just like that. If you want to write 8.5, you can absolutely write 8.5, but it's not necessary. All right, can we go to number 2? All right, 5577. Is this a triple? No. Do you think it'd be fun doing the Pythagorean theorem on 55 and 77?
Sure.
No, that is not fun squaring those big numbers.
Not
So
fun, but it's doable.
it's all doable. All right, so now what we're going to do you think we want to create a bigger triangle or a smaller? Yeah, so we're going to create a similar triangle but have it be smaller. What am I going to divide by? 11. So now we're going to have 5 and 7, and then I'm going to call the missing side y. How come I'm not calling it x? Yeah, because x is not the same, right? The y, the side that's labeled y and the side that's labeled x, they're not the same length, so I can't use the same variable to represent them. Okay, so right now, is this a triple? Something 5, 7. No, so what should I do? Pythagorean theorem. Who can set up the Pythagorean theorem for me here? Sion, thank you.
5 squared plus 7 squared equals x squared, or y squared.
Are you sure?
No.
Oh, wait, no. 5 squared plus y squared equals 7 squared.
You got it. 5 squared plus y squared equals 7 squared. So we are 25 plus y squared equals 49. Subtract that 25 on both sides. We get y squared is equal to 24. Root both sides. Can anybody simplify this radical in their head? Sion?
2 root 8.
2 root 8. No. You're close, though. Fix your radical. 2 root 6. You got it. What did we do? We thought of the biggest perfect square that goes into 24. What's the biggest perfect square that goes into 24? 4. 4 times what gives us 24? 6. So that's how we get the 2 root 6. So now this is not my answer. Y is 2 root 6. What do I need to do to go back to x? Good. Now we're going to multiply by 11. So we're going to do 11 times 2 root 6, which is 22 root 6 for x. Are we ready for the next one? All right, triple, yes or no? Yes, no, yes, no. How many people say yes? How many people say no? All right, it is a no. Why is this not a triple, even though I see a 3 and a 4? Max. Good. If this were a 3, 4, 5 triple, the hypotenuse would have to be 5. All right, here the hypotenuse is 4, so this is not a triple. Does it make any sense to reduce or enlarge this triangle? No. What should we just do?
Solve.
We just solve using the Pythagorean theorem. Can somebody set up the Pythagorean theorem for me?
3 squared plus x squared equals 4 squared.
You got it. 9 plus x squared equals 16. Subtract that 9, we get x squared equals 7. Root both sides, x is equal to the root of 7. All right, can we keep going? All right, so once again, we want to find the hypotenuse. Unfortunately, there's nothing you can do about radicals. But I do have 6 and 18. 18 is a pretty big number. So can I still reduce this triangle to make those coefficients a little smaller? Yeah, so let's do that. So I'm going to go ahead and I'm going to divide not by 3. What's bigger than 3 that I can divide by? 6. So I'm going to create a new smaller triangle by dividing by 6. And then I get a 1. And then what's 18 root 3 divided by 6? 3 root 3. And I'm going to call the missing side y. Can someone set up this Pythagorean theorem for me? Maya.
1 squared plus 3, wait, in parentheses, 3 root 3 squared.
3 root 3 squared. Good.
Equals y squared.
Perfect. So then this is 1. 1 squared is just 1. Now remember, this is 3 root 3 times another 3 root 3. Okay, when you're multiplying this, multiply your coefficients. 3 times 3 is 9. Then you multiply your radicals. What is root 3 times root 3? Whole number 3. So then this is 1 plus 27 equals y squared. 28 equals y squared. Now we root both sides. Can somebody simplify this radical? Good, Sam. 2 root 7. Is that my final answer? 2 root 7? No.
Oh, yeah.
This triangle has a hypotenuse of 2 root 7. But what do I have to do to get back to the other triangle? So the hypotenuse of the original triangle is not 2 root 7. It is 12 root 7. You got it. All right, I'll give you a minute to finish copying if you're still writing. You know what? Before we start doing any of the quadrilaterals, can we go to the end here? Do you guys see how there's an empty page at the end? All right, I'm gonna put some more. I'm gonna put some more to show you. So, hold on. Is that what I wanted? That's not what I wanted. Hold on. Okay. This is what I wanted. Sorry. Okay, so root 3, root 4. Are root 3 and whole number 3 the same thing?
No.
No. Root 3 and whole number 3 are not the same thing. So do you think this counts as the 3, 4, 5 triple?
No.
No. A lot of students just think this is root 5. It's not, because radicals and whole numbers aren't the same thing. So this is not a triple. What do I have to do to this triangle? The Pythagorean theorem. So I'm going to do root 3 squared plus root 4 squared equals x squared. What's root 3 squared? 3. What's root 4 squared?
4.
What's 3 plus 4? Is this the same as root 5? No. So be very careful. Don't let me trick you. Don't let me trick you. Right, another one. Yes. That would be 0.5. So let's go back to the decimals. I was going to do that one next, actually, but I just wanted to show you the radicals first. So if I have 0.3, 0.4. Right, just to be safe, if I were you, just to be safe, to get rid of the decimal, what can I multiply by? 10. So just to be safe, I would create a bigger triangle, and then when I multiply it by 10, wouldn't this be a 3 and a 4? Now, is this a triple?
Yes.
3, 4,
5.
5. So then to go back, what am I going to do?
Divide by 10.
Divide by 10. So what is the hypotenuse here? 0.5, exactly. All right, I'm going to give you one more.
For the first example that you drew, like since like the root root 3 is just 3, like root 3 squared is just 3, and root 4 squared is just 4, can't you just like write the 3 and the 4 there and then it would be 5? Like if those simplify out, like if you were to do it, wait, hold on, because like if you do the the first step of the Pythagorean theorem for the 3 and the 4, it would just be like actually just 3 and 4, right?
Yeah, oh, you mean like almost like what we're doing here when we're creating similar.
Kind of.
Okay, so your only way to reduce or enlarge the triangles is never to square. You can't just square a triangle. The only way to do it is through multiplication. So you multiply the whole thing by some number or divide the whole thing by some number. So here, to get rid of those radicals, you'd have to square them. But squaring them is not equivalent to multiplying by the same number to anything. Does that make sense what I'm saying? Okay. All right, next one. Let's say I have, I want to solve for y. Should we do the Pythagorean theorem on 2 1/3? No. So what I would recommend we do is I would recommend we change this to an improper fraction. How do I change 2 1/3 to an improper fraction? You multiply 3 times 2, which is 6, and then you add the numerator, plus 1 is 7. So do we agree 2 1/3 is 7/3? All right, I do not want to do the Pythagorean theorem on fractions. So what can I multiply 7/3 by to get the 3 denominator to cancel out? 3. You multiply 7/3 by 3 to cancel out the denominator of 3, right? So we're going to multiply that whole thing by the denominator of 3. And when I multiply by 3, 7/3 becomes 7. 4 times 3 is 12, and then x. What would I have to do now? The Pythagorean theorem. So we are 7 squared plus 12 squared equals x squared. 49 plus 144 equals x squared. What's 49 plus 144? Did anybody add it? 193. Root both sides. Does 193 have any pairs? No. So x is equal to the root of 193. That's not my answer. What should I do? Divide by 3. Is it okay if I write root 193 over 3? Is that acceptable? Absolutely. I'm sorry? You can't divide the 3 because 193 is a radical and 3 is a whole number. You can't divide radicals in whole numbers. Okay, so I think those are all the little tricks I might have had up my sleeve that you might see on tests or quizzes. Do we understand all of these? Okay, so let's go back. to this. All right, it says we have a rhombus, rhombus ABCD. AC is 20, BD is 48. Find the perimeter. All right, first thing we need to do is remember some properties on a rhombus. What do we know about all sides of a rhombus? They are congruent. Right? You also have to remember that the diagonals are perpendicular. Right? And the diagonals bisect each other. So if all of AC is 20, what's AE and EC? 10. If all of BD is 48, what is DE and EB? 24. Now, do we agree we can represent every side with X since they're all the same? Hey, what am I going to do? I'm going to take one of the triangles. Does it matter which triangle I take? It does not matter which triangle we take. Here's 24, here's 10, here's X. I do not want to do the Pythagorean theorem on 24 and 10 because 24 is big. 24 is a big number. So what can I do so I don't have to do the Pythagorean theorem on such big numbers? Good. What's the best number to divide by? 2. So now I'm creating a new smaller triangle. 24 divided by 2 is 12. 10 divided by 2 is 5. This is a triple. 5, 12, what is it? 13. Is my side length 13?
No.
No.
Multiply.
We got to go back and multiply by 2. So what does X equal? 26. So BC is 26. That means AB is 26. AD is 26. DC is 26. Can we now find the perimeter? Yeah, the perimeter is going to be 4 times 26, which is 104. Thank you. All right, number 6 is a little bit challenging, and I would absolutely expect something like this. Showing up quiz test on something. All right, given isosceles trapezoid WXYZ, we're being told that ZY is 4, that an altitude is 6. I'm going to remember that. I'm not going to draw it in just yet. And XY is 10. Well, if XY is 10 and they said it's an isosceles trapezoid, what else is 10? WZ. All right, for the purpose of this, find the length of a diagonal. For the purpose of this problem, I'm going to redraw this trapezoid so it's sitting on the bigger base so we're not looking at it upside down. Okay, so I'm going to redraw this. It's not necessary. I just think visually it helps a little bit so that we redraw so it's sitting on the bigger base. All right, they said altitude is 6. I'm going to start off by drawing one altitude, but how many can I draw? I can draw 2. I'm going to start off drawing one altitude, but I can draw 2, and eventually I will. I'm going to call the altitude ZP. So I'm drawing it from Z to P, and that makes right angles. They said find the length of a diagonal of WZYX. Well, doesn't a diagonal have to start at a vertex and go to a non-consecutive vertex? So I'm going to draw my diagonal from Z to X. Do we agree that this altitude they told us was 6? Do we all agree I need to find ZX? That's what I'm trying to find. It says find the length of the diagonal. So ultimately, I need to find the length of ZX. All right. Well, what do I see? Yeah, do you all see this triangle right here? If I'm able to figure out how long PX is, can I then do the Pythagorean theorem to find ZX? Yeah. So right now, my main goal is to find the length of PX, but now I got to figure out how I'm going to find the length of PX. Well, we do know that we are allowed to draw in another altitude. Do we agree? There's the other altitude there. And now when I draw in that other altitude, remember from last class, we have 2 right triangles, and what's in the middle? A rectangle. We have 2 right triangles and a rectangle in the middle. In a rectangle, aren't opposite sides congruent? Yeah. So if the top of that rectangle is 4, what's the bottom side of that rectangle? 4. Let's call this YM. So PM has to be 4. All right, let's keep going. Remember, ZYMP is a rectangle. If ZP is 6, what does YM have to be? 6. So now what I'm going to do is I'm going to take this triangle, YMX, which has a 6 and a 10, and I'm going to find the length of MX. Can I divide this triangle by 2? Yeah, I'm going to divide this triangle by 2, and I'm going to get a 3 and a 5. This is a triple, 3 something 5. 4. Is MX 4? We got to multiply by 2. So what's MX? 8. MX is 8. Do I now have the total length of P to X? Yeah, P to X is not 4. It's not 8. How long is it? 12. So now, let's look at our triangle. Z, P, X. I have a 6 and I have a 12. Can I divide this triangle to make it smaller?
Yeah.
Yeah, let's divide by 6. So I have a 1 and a 2. Unfortunately, it's not a triple. What should I do? The Pythagorean theorem. 1 squared plus 2 squared equals, I don't know, let's call this, I've like used every letter in this alphabet. C, we could use C, equals C squared. 1 plus 4 equals C squared. What does C equal? Root 5, right? C equals root 5. So now C is equal to root 5, but when I go multiply back, what do I have to do? Multiply by 6. So it's not root 30. What is it? It is 6 root 5. Did we find the length of the diagonal? Yes. Should you know how to do something like this? Yes. All right. I'm going to do number 8 and then I'll go back to number 7. There's definitely a question like number 8 also. I don't know if it's on the quiz or on the test, but it's showing up on something. I can tell you that much. And it's also involved. A boat is tied to a pier by a 25-foot rope. The pier is 15 feet above the boat. If 8 feet of the rope is pulled in, how many feet will the boat move closer to the pier? All right, half the problem here is creating the diagram. So let's see what's going on. All right, so here's our water. And a boat is tied to a pier by a 25-foot rope. The pier is 15 feet above the boat. So because they said the pier is 15 feet above the boat, they're giving the pier height, right? So here's our pier. How tall is this pier? 15. Are we okay so far? All right, and what's happening? From the pier, we're tying a rope to a boat. I'm going to write boat position 1. So a boat is tied to a pier by a 25-foot rope. Where am I labeling the 25 feet? The hypotenuse. Good. The hypotenuse is 25 feet. Are we still okay? Still okay with everything I've done? All right, so now here's where it gets a little bit complicated. Now they're saying we are going to pull in that rope 8 feet. If I'm pulling in that rope 8 feet, is that boat going to move closer to the pier, or is it going to move further away from the pier? Good. If I'm pulling in that rope 8 feet, now that boat is moving closer to the pier. So here we're going to have boat position 2. Can I figure out how long this new rope is? How? How will I figure that out? Good, Mia. 25 minus 8, which is 17. All right, now what is it asking for? It is asking how many feet will the boat move closer to the pier? So really what they're asking for is that distance right there. Do we see that? Because here we were, position 1, and then I moved closer to the pier to get position 2. So they want to know, how much closer did I move? How much did I move from position 1 to position 2? Is everybody okay? I'm not asking for 17. I'm not asking how many feet shorter is the rope. I'm asking how much closer did we move? How much space did I move from position 1 to position 2? So this is what we're trying to find. All right, the biggest mistake is that everybody, do you guys see this triangle? Everybody likes to use that triangle if they mess up. They use this triangle and they say this is 17 and this is 25, and then they're doing the Pythagorean theorem on 17 plus x squared equals 25 squared. Why is that wrong? Excellent. If you understand the Pythagorean theorem, you know the Pythagorean theorem could only be used on what kinds of triangles? Right triangles. Is this a right triangle? No. So that is why we cannot do this. Do I have right triangles? I do, because the pier makes a right angle with the water. So this is going to be a multi-step process. Do you all see the bigger triangle? Do you guys see that bigger one? I'm going to call that base Y. So here I have 15 and 25, and I have Y. I can divide this triangle by 5. When I divide the triangle by 5, I get a 3 and a 5. Is this a triple? Yeah, 3, 4, 5. Go multiply back. What is Y? 20. Is 20 my answer? No. Any guesses on what I'm going to tell you to do now?
Look for,
Adrian?
Find the triangle to the left and then subtract the...
You got it. Do you guys see this yellow triangle? This is 15. This is blank. This is 17. This is another triple, something 15, 17. Oscar? 8. You got it. So this part is 8. How am I going to find x? You got it. X is going to be 20 minus 8, which is 12 feet. Yes, Maya?
Where'd you get the 8 from?
Do you see this yellow triangle? Do you see 15, the hypotenuse is 17? It's a triple. 8, 15, 17. It's one of the ones I'm making you memorize. All right, one last problem together. Oh, no, don't do that. Okay, one last problem together. All right, so we have a kite. So what else do we have to remember? Properties of a kite. So far we've had a rhombus we had to memorize, rectangle we had to memorize. We got to memorize kite too. Well, not memorize, remember the properties. All right, kite, A, B, C, D with AB congruent to AD. So therefore, since it's a kite, don't we know that BC and CD have to be congruent? They're telling us that AB is 13. If AB is 13, what else is 13? AD is 13. Then they're telling us that AE is 5. And we are told the perimeter of ABCD is 56. Since the whole perimeter is 56, anybody know how I can find BC and CD? Michael? Good. 56 minus 13 plus 13. So it's 56 minus 26, which is 30. Then what are we going to do? 30 divided by 2, which is 15. So BC is 15 and CD is 15. Do you all agree that in a kite the diagonals are perpendicular? And you also have to remember that the long diagonal does what to the short diagonal? Bisects it. So look at here. We have a triple going on. 5 something 13. Anybody remember what that one is? Not 7. 12. 5, 12, 13. If ED is 12, is BE also 12? Yes. What were we asked to find? EC. So to find EC, I'm going to work on this blue triangle. Do y'all see that blue triangle? All right, this is 12. The hypotenuse is 15. I'm going to divide. What do you think I'm dividing by? 3. So then we're going to have a 4 and a 5. Is it a triple? It sure is. Something 4, 5. 3. Go back and multiply by 3. What's EC? 9. Are the triples helpful? Yes. All right. Homework. Oh, I need to do number 3 with you. Do I have time? Yes. Okay. I would also expect something like number 3. So we have a rhombus. Guess what I'm drawing? A rhombus. All right. It says the perimeter of the rhombus is 16 root 3. Do we agree that all sides of a rhombus are congruent? So what we're going to do is 16 root 3 divided by 4, which is 4 root 3. Every side is 4 root 3. And then it says one diagonal is 8 root 2. Find the other diagonal. So do I need to draw in both diagonals?
No.
Yeah.
Wait, yeah.
Yeah, I need to draw on both diagonals. So now you need to remember in a rhombus the diagonals are perpendicular, but they also do what to each other? Bisect each other. So if one diagonal is 8 root 2, each half of it has to be 4 root 2, 4 root 2. And is it okay if I call this x and this x? Now, I'm not trying to find x. What am I trying to find? The whole thing. But if I find x, can I find the whole thing? Yes. How am I going to find x? Use one of the right triangles. So this is x, this is 4 root 2, this is 4 root 3. Can I divide by 4? Sure.
Yeah.
So then we have root 3 and root 2, and here's y. All right, so now I'm going to have y squared plus root 2 squared equals root 3 squared. So y squared plus 2 equals 3. Y squared equals 1. So what does y equal?
1.
1. If y is equal to 1, what's x?
X is just 4.
4. Is that the length of my other diagonal?
Yeah.
No.
No.
X is 4. X is 4. Remember, diagonal has to go from corner to corner. Diagonal 2 equals 8. All right. How did I get what? We had to multiply back by 4. All right, homework. Homework is textbook. Study for Do Now quiz. The Do Now quiz is me giving you a piece of paper, you're writing down the triples. That is it. Right? Me giving you a piece of paper, all you're doing is writing down the triples. Friday. I'm going to post this on Google Classroom, yes. You're not here? Where are you going to be? Swimming? Snowboarding, how fun. It's right.